Welcome back to Lesson 2, or Lesson 4.4. We're talking today about factoring using common factors, factoring by grouping, and factoring by difference of squares. And in fact, this first one is going to be greatest common factor, but we'll come back to that in a second. So factoring is something you've done in Algebra 1 and Algebra 2. It's the process of breaking up products into different factors or smaller factors. Two things that multiply together. So the first thing we're going to do is just a little warm up, and we're going to factor 2x plus 4. Now in this case what we're looking for is a greatest common factor, or a GCF. So what you do is you look at each term in the expression, this is an expression, look at each term, 2x and 4, and see if they share a common factor. Can they both be divided by a number evenly, the same number evenly? In this case, 2x and 4 can both be divided by 2 evenly. Now when you do that, the 2's would cancel out here. You would have an x. 4 divided by 2 would be 2. And whatever you divided by needs to go outside. So now this is the greatest common factor of 2x plus 4, and it is 2 times x plus 2. So that's a very simple one. Often what we're going to see is going to be slightly more complex. So 6x squared minus 5x, or sorry, minus 8x plus 12. And what you would look for here is the same idea. We're going to look for a GCF. So we look at each term, 6x squared, 8x, and 12. They each share a factor, again, of 2. So whatever the common factor is, you're going to put on the outside, and then you are going to divide each term by that common factor. So 6x squared divided by 2 leaves me with 3x squared. Negative 8x divided by 2 leaves me with negative 4x. And 12 divided by 2 leaves me with 6. So for today's lesson, we are not going to attempt to further break apart this inside thing. We're just looking for greatest common factors at this point. Okay? So, for example example 3, let's say. We are going to factor out 2. And this is going to be an example where the numbers you're given aren't always necessarily the numbers that need to be factored out. And this will come in handy later in the year when we get to some other materials as well. So if you look, we have 2x squared minus 5x plus 4. These do not share a common factor of 2. But the question is asking us, as it will in the assignment, to factor out 2 anyway. Now the reason for this is because there are some lessons we'll go to where we want to have this quadratic function, x squared plus something x plus a number, have no value in front of the x squared, have it just be 1x squared. And so that's when that would come in handy. We're going to divide everything by 2 here and just do what it says. So 2x squared divided by 2 becomes x squared. The negative 5x divided by 2 doesn't divide evenly, but what you would do is you would just leave it as negative 5 halves x. Okay? And then 4 divided by 2 would be 2. So for a problem that's a little more complicated like this, we can use the methods we used on the last lesson to determine whether or not our answer is correct. So we can take this first thing and put it into y1, take the second thing and put it into y2, and the answers in the y columns should be the same as they were yesterday, or the other day. So let's take a look. The first is 2x squared minus 5x plus 4. And we're saying that we divided it by 2 and got 2 parentheses x squared minus 5, get that right, 5 halves x plus 2. Plug those in, check the table, and again your second 2 columns should be identical every time. Okay, and we're going to use this method a whole bunch as we go forward. For the next example, we're going to try something very similar. We are going to, instead of factoring out 2, we want to factor out 5. Okay? And let's say we use 5x squared plus 4x plus 1. So in this case, we're going to factor out 5. Again, we're doing this specifically because we want the x squared at the beginning to be by itself. So that's why we're taking the coefficient of x squared and factoring it out. So I'm going to say 5x squared divided by 5 is going to be x squared. 4 divided by 5 does not divide evenly, so we're going to leave it. And 1 divided by 5 does not divide evenly either. Okay? So this, again, we can plug this into y1, plug this into y2, and check to make sure that our solutions are correct. So let me see if I can get this on the screen here. So let's say 5x squared plus 4x plus 1. On the second line, 5 times x squared plus 4/5 x plus 1/5, and then check our table to make sure that our last two columns are identical. So that is just basic factoring out a common factor. The next thing we're going to do is we are going to factor by grouping. Now, factoring by grouping is another extended method of doing what we just did. It's factoring out a common factor, and we can do this when we have terms that have even numbers, or a polynomial has an even number of terms. So, for example, if we have 2x squared plus x plus 6x plus 3. This is a polynomial with an even number of terms. Now, we could simplify this, and in the future we would simplify this, but for the purpose of doing what we're doing right now, we are going to instead use these even numbers of terms to factor this thing by grouping. Now, grouping means you take the first pair and turn it into a group, take the second pair and also turn it into a group. And we are going to do the method that we used here by finding a GCF on each of these two terms. Okay? So what you're going to do is, you're going to look here, 2x squared and x. Well, just for the purpose of argument, whenever there's a regular x, it's just a 1. Now, in the other problem, we had a common factor of 2. In this one, we don't have a numerical common factor, but these two terms both share a factor of x. So we can divide an x out of each term. When we do that, that x goes to the front. 2x squared divided by x, well, the 2 doesn't have anything to divide it away. X squared divided by x leaves 1x. And then 1x divided by x, the x's would cancel and I would get just plus 1. If we look at the second set of terms here, we have 6x plus 3. Now 6 and 3 share a common factor of 3. Okay, so this is going to be 3 on the outside. 6x divided by 3, well, 6 divided by 3 is 2. X has nothing to cancel out, so it's going to drop down. And then 3 divided by 3 is 1. What you're going to do then, always, is you're going to take whatever sign is in front of this 6x, and that's going to be the sign that you are actually dividing by. Okay, so this becomes plus 3. Now, if you look here, we have a mostly factored polynomial. But what's important to note is that this factor here and this factor here are identical. What that means is that we can put them together as a common factor of these things. What you would do then is take the two numbers that are in front, and those will create their own factor. Now, again, we can check this answer. Where you want to start from is the very beginning problem. Okay, so you're going to start from the first part, not anything that you did in between, because this is where mistakes get made. You're going to start from the beginning. This is going to be in y1, and this one down here will be in y2. So we're going to do the same thing we did on the last one. We're going to say 2x squared plus x plus 6x plus 3 on the first line. On the second line, we are going to put what we think the answer is, x plus 3 times 2x plus 1. We can go and check the tables, and again, the last two columns should be identical. Okay, so that's another method of checking your work. Now, our next example is going to be very similar. This would be example number 5. The last one should have been 5, but I forgot to number it, so we'll just number this one. And we are going to factor by grouping 12x squared minus 8x plus 15x minus 10. Now, one thing that these problems are already doing that you should still be paying attention to, is they are listing their terms from highest exponent to lowest. These two in the middle are already broken up into two different things. We're going to leave that alone for right now. But they should always be x squared, then the regular x's, and then a number, or if it's x cubed is biggest, that needs to go first, kind of like we did on the last lesson. Here we have 4 terms, so we're going to go ahead and break them up again into 2 pairs. And I want to point out right here that, see where I'm breaking this group? It's between this value and before this plus or minus, whatever that plus or minus is. We're actually going to do this problem twice. I'm going to flip it around a little bit in a second. So we're going to look here, 12x squared minus 8x. 12 and 8 share a common factor. They share a couple, but we're looking for the greatest common factor. So the greatest common factor of 12 and 8 would be 4. Okay? 2 is a common factor, yes, but they also divide by 4, and if at all possible, we want to take out the largest one. Now, they also both share an x. This one has x squared and this one has an x. So we're going to divide out 4x from each of these. So 4x is going to go out in front. Oops. 4x. 12 divided by 4 is 3. X squared divided by x leaves 1x. Negative 8 divided by 4 is negative 2. X divided by x would cancel out. Now 15x and negative 10. They share a common factor of 5. And it's a positive 5 because this value here is positive, which means that this value down here is going to be positive as well. Now 15 divided by 5 is 3. X has nothing to cancel it out, so it continues down. Negative 10 divided by 5 is negative 2. And we have the same pattern we had a moment ago. These factors here are identical, so they are going to be combined into a single number, or a single set of parentheses. And then we have the 4x on the outside plus 5 on the outside. So 4x plus 5 is my other factor. Check our answers using y1 and y2 to make sure that we've done this correctly. So 12x squared minus 8x plus 15x minus 10 on the first line. My second line will be what I believe to be the answer, 4x plus 5 times 3x minus 2. Enter, check my tables, and sure enough, my answers are identical again. Now, we're going to do this same problem, but instead of the negative 8x first and the positive 15x second, we're going to flip those two middle ones, just to show you that the order of the 4 items doesn't matter too much, as long as they're ordered from biggest exponent to smallest. So we're going to do a little bit of an extra one here. We're going to take that 12x squared. We are going to put the plus 15x first, the minus 8x second, and the minus 10 third. So we just flipped the two middle numbers. And I want to do this for a very specific reason. So if we group these, like so, and now we're going to look at these two factors and see if they have common factor. So 12x squared and 15x. 12 and 15 share a common factor of 3. It's the greatest common factor between the two of them. In this case, they also share an x, just like in the last problem. So we have a 3x on the outside here. 12 divided by 3 is 4. X squared divided by x leaves just 1x. 15 divided by 3 is 5. and x divided by x cancels out. Now the most important reason I wanted to look at this problem is because now we have the negative number in the second group, which is going to change things a little bit. So what you're going to do is look at the numbers 8 and 10. What is the greatest common factor between 8 and 10? And the answer is 2. But because this value is negative, it means that this value needs to be negative as well. So we're not going to divide just by 2, we're going to divide by negative 2. Now, negative 8 divided by negative 2 is positive 4. The x has nothing to cancel it out, so it comes down. Negative 10 divided by negative 2 is positive 5. Same pattern, 4x plus 5 here, 4x plus 5 here. It's going to combine together into a single term. The 3x and the minus 2 are going to make up our other term. Now if you look at these two answers, they're identical. Okay? In this case, the factors have flipped. So the 4x plus 5 is second here, and the 3x minus 2 is first here. The order that these two factors are in does not matter, but the 3x minus 2 has to be in the same set of parentheses, and the 4x plus 5 has to be in the same set of parentheses. If you get the signs switched on these, it doesn't work. So we're going to go ahead and check just to make sure that this is correct. We have y1 and y2. Just up a bit. We are going to rewrite this whole thing because I switched it around a bit. 12x squared plus 15x minus 8x minus 10. And then we are going to flip the order of our factors here. 3x minus 2 times 4x plus 5 should get identical answers over here as well. So that's something I wanted to show to make sure that we saw those things. All right. So moving on to the last part of this lesson. The last part of this lesson is regarding difference of squares. And this is something we talked about in different terms in the day when we were multiplying polynomial terms together. We said that when a squared, or let's continue, start a different way. We said that when a plus b is multiplied times a minus b, and these are referred to as conjugates, the result is a squared minus b squared. Okay? So we can use this information that we used the other day to multiply things together. We can use it in order to factor them as well. So we're going to go on to example 6 here. So we are going to factor x squared minus 4. Now basically what this does when we do this process is we're going to take whatever a is, or a squared. Okay, so you're going to take this x squared and you are going to find out what the square root of that is. Okay, and you are going to take the value of b, whatever that is, in this case 4, find out what the square root of that is. Okay, so the square root of x squared is just going to be x. The square root of 4 is going to be 2. Now, those are our a and our b. So that means my first set is x plus 2. My second set is going to be x minus 2. Again, we can check these using the calculator. We put this into y1, we put this into y2. This will be a little faster. X squared minus 4. Oops, clear that. X plus 2, x minus 2. I meant to do a table, but you'll see here that it only makes one graph. The reason it only makes one graph is because they're sitting on top of each other, because my y's are all identical. So if we go down to do another example, let's say x squared minus 25, you are going to find the square root of the first thing and the square root of the second thing. Okay, and this only works if both terms are perfect squares, like 25 is a perfect square. So that means that this is going to be x, this is going to be 5, this is a plus, that one's a minus. Pretty simple. Now, for this one, we're going to kick it up a little bit. We have 4x squared minus 49. Now, this is also a set of perfect squares. 4 is a perfect square, x squared is a perfect square, and 49 is a perfect square. So we can use this factoring method. Square root of 4 is 2, square root of x squared is x, the square root of 49 is 7. So my first factor will be 2x plus 7, my second factor will be 2x minus 7. Couple more. So if we have an example of 9x squared minus 16. Again, 9 is a perfect square, x squared is a perfect square, and 16 is also a perfect square. So these can be done. Square root of 9 is 3, square root of x squared is x, square root of 16 is 4. There's my first factor, and then 3x minus 4 is my second factor. So these are the fairly simple ones. I'm going to do one more really quickly just to show you guys how this can be a tiny bit more complicated from time to time. So let's say, for example, we have, let me think of a good one. Let's say 18 x squared, let's say minus 1. Okay, this is one that tends to get people confused because they look at that 1 at the end and don't really know what to do with it. Actually, let's make this 2. Okay, let's make that a 2. Now, neither 18 nor 2 are perfect squares. Okay, if you take the square of those numbers, you're not going to get a good number. However, they also share a common factor. They share a common factor of 2. So you can divide these out, and you will get 9x squared minus 1. Okay, now in order to completely factor this, you can look at the 9x squared and the 1, and these are now perfect squares. 9x squared is a perfect square. Square root of 9 is 3, square root of x squared is x, and the one that people often get tripped up by is 1, but the square root of 1 is just 1. So we can break up this inside term into 3x plus 1 and 3x minus 1. The only thing we have to be sure of is that we remember to bring this 2 down because it is a part of the answer. So in order to check this one, we would again plug this into y1, plug this into y2, and check our answers. Make a little room here. So we're going to start here. 18x squared minus 2. We believe the answer to be 2 times 3x plus 1 times 3x minus 1, and we are going to check the table to make sure that all of my y values are perfect. And that is the first lesson in factoring. Your next lesson will be factoring trinomials, which is what you've worked on many, many, many times over the course of the years, but I have a method that I think is pretty darn good. So here ends the lesson.